Hi students, how are you? So, in my previous session, I explained about the classes of material that we come across and we see used in different applications. Today, I am going to discuss how those materials are synthesized and what are the type of chemical interaction that exist between the atoms of materials. First, let us see quickly what are these primary and secondary interaction. The first type of primary interaction is ionic bonding. It is always formed between metal cations and non-metal anions. So, an electropositive element and electronegative element combines to form ionic bond. Electropositive elements are metal, electronegative elements are non-metals. In this case, the oppositely charged ions, they stick to each other like magnets. So, metals acquire positive charge, non-metals acquire negative charge, and in the process of bond formation, metals lose electron and non-metals gain electron. So, it is a win-win situation for both to get involved in bonding. Look at the best example, sodium chloride. Sodium is a metallic atom, chloride is a non-metal. Sodium donates one electron, chlorine accepts that electron. And in this process, by losing electron, sodium acquires stability. By gaining electron, chlorine acquires stability. If you see the electronic configuration of sodium, there is one electron in the valence shell of sodium, 1s2, 2s2, 2p6, 3s1. The configuration is 3s1, valence shell is 3s1. And chloride as 1s2, 2s2, 2p6, 3s2, 3p5, one electron is short here. So, if sodium gives this one electron present in the 3s valence orbital to chlorine, then that the 3p5 after gaining one electron, this becomes 3p6. So, what happens? Total number of electrons in sodium after losing electron becomes 10 and total number of electron in chlorine after gaining electron becomes 18. So, sodium become 10, sodium the total electron become 10 after bonding, chlorine become 18. That means, the sodium acquires the configuration of inert gas neon, chlorine acquires the configuration of the inert gas argon. So, in that way both the atoms they acquire stability. That means, when two atoms sodium and chlorine they get involved in ionic bonding, both of the atoms they acquire stability by reaching the configuration of noble gas. All of you know noble gas are very stable, they are inert. So, any atom whose electronic configuration becomes equal to the noble gas configuration, then they acquire stability. So, if you see ionic bonding are found in ceramic materials, ionic solids. Look at this picture. This is a very good explanation, very interesting explanation. So, during the formation of sodium chloride bond, what did the atom of chlorine say to the atom of sodium? Chlorine said to the sodium, you complete me. Whatever happens in case of a perfect couple, what is the expectation, aspiration of each of the partner? Each one thinks the other one should complete him or her. The same thing happens. Sodium completes the aspiration of chlorine, the requirement of chlorine. Chlorine completes the requirement of sodium. In that way, both get involved in the bonding. The next type of primary interaction is metallic bonding. It is formed between metals, atoms of same metal or two metals. Example is solid gold, silver, lead, copper, chromium, all the metals they involve the metallic bonding. Here the bonding is, the mechanism is completely different from ionic bonding. Here what happens? The metals have the tendency to lose electron and acquire positive charge, and the electrons released by the metallic atoms, they float freely in the lattice, and the metallic nuclei are considered or thought to be floating inside the sea of electrons. This is called the sea of electrons. Sea of electrons. And what happens? As there is abundance of free electrons are there in the metal, that makes the metal good conductor of both heat as well as electricity. So, metals are good conductors, they can easily conduct the thermal energy as well as electrical energy because of the availability of plenty of electrons. The materials like metals, different alloys, they contain metallic bonding. Then the third type of primary interaction is covalent bonding. Unlike ionic bond where there is a complete transfer of electron from one atom to the other, here in covalent bonding, the electrons are shared between two non-metal atoms. Look at the difference here. In ionic bonding, one metal plus one non-metal. Here in covalent bonding, two non-metal atoms, they combine with each other to form the covalent bond. And how do they combine? Each of the non-metal atom contributes pair of one electron. So, the pair of electrons shared between the two non-metal atoms, and by exercising, by using that pair of electron, each of the participating atom acquire the electronic configuration of noble gas. Here you try to understand water. This is the molecule of water. Oxygen has 6 electrons in the outer orbit, the outer shell. So, this is one pair of electrons shared with hydrogen, this is another pair of electrons shared with hydrogen. That means, when hydrogen makes use of the electron pair, it acquires the electronic configuration of helium. Hydrogen, when makes use of the electron pair, it acquires the electronic configuration of helium. Similarly, when oxygen makes use of both the electron pair, it acquires the configuration of neon 10, the noble gas. So, by sharing the electron pair between the participating atom, each one of the atom acquires the electron configuration of noble gas, so that they become stable. So, the atoms always try to complete their valence shell, either 2 or 8. 2 will do, but 8 is great. See here, number of electron the atom need is the total number of bonds they can make. So, hydrogen requires 1 electron to acquire the configuration of noble gas. That means, hydrogen forms 1 covalent bond. Oxygen requires 2 electrons to acquire the noble gas configuration. That is why oxygen forms 2 bonds. Fluorine forms 1 bond. Nitrogen forms 3 covalent bond. Chlorine forms 1 covalent bond. Carbon forms 4 covalent bond. That is why we call carbon as tetravalent. So, what type of material contain covalent bond? Polymers, ceramics, composites. Now, no bond is 100% covalent or 100% ionic. Always there is a percentage distribution of ionic character and covalent character. So, this ionic character refers to the bond's polarity. So, in a polar covalent bond, if the electronegativity difference between the two participating atoms is 2, then it is more polar in character, and the closer the electron negativity difference is 0.2, the more non-polar is character. That means, covalent bond in which the electronegativity difference of the participating atom is 0.2 and below, such bonds are non-polar, and when the electronegativity difference between the participating atom is around 2, then it is more polar in character. See here the polar molecule and non-polar molecule. Hydrogen chloride, which we call as hydrochloric acid. See, the hydrogen, it has acquired the noble gas configuration when it makes use of the pair of electron. Hydrogen becomes resemble helium, and chlorine, when it makes use of the shared pair of electron, then it acquires the configuration of argon. It acquires the configuration of argon 18. But what happens here? There is unequal sharing of electron. Most of the electrons are located on the chloride side. That is why a delta minus charge is developed on the electronegative chlorine than hydrogen, and hydrogen side delta plus charge is developed. Such molecules are called polar molecules because the covalent bond is polar in nature, because electronegativity difference between the participating atom is more. Whereas a non-polar molecule, you see there is a equal sharing of electron. Each chlorine on the either side, they are surrounded by the same number of electrons. So, chlorine molecule is non-polar, whereas HCl molecule is polar, because the covalent bond is in chlorine molecule is non-polar. Electronegativity difference is minimum, whereas in HCl the electronegativity difference is maximum. Next, we will see the secondary interaction. As I mentioned earlier, secondary interactions are intermolecular interaction that includes the attraction between molecules. Example, hydrogen bonding, dipole-dipole interaction and induced dipole interaction. Hydrogen bonding involves strong attraction between special polar molecules. That means hydrogen bonding is exhibited by those molecules where the high electronegative atoms are present. See here, strong intermolecular force act like magnets, occurs only between hydrogen of one molecule and high electronegative atoms of another molecule. Like high electronegative atom means nitrogen, oxygen, fluorine. So, the bonding that takes place between the high electronegative atom on one molecule and hydrogen of the other molecule. You can see this is the hydrogen bond, the dashed structure given. Why? This bond is not permanent. Hydrogen bond is not permanent, unlike the primary interaction. Means when the hydrogen and oxygen, they come in closure to a minimum distance of separation, such bond formation takes place. Once the distance of separation between oxygen and hydrogen increases, the bond ceases to exist. No bond formation will take place. Next is dipole-dipole interaction. This is a weak intermolecular interaction, only occur between polar covalent molecules. So, what happens? The partial negative charge and partial positive charge of two adjacent molecules, they interact with each other. You can see here the partial negative charge of the molecule ICl interacts with the partial positive charge of the another molecule. This is called the permanent dipole interaction. In 3 dimensions, you can see how the network of interaction takes place, both attraction as well as repulsion. Always you will see that delta plus of one molecule is attracted towards the delta minus of the other molecule. Third type is induced dipole interaction. This occurs between a polar molecule and a non-polar molecule. So, in presence of the polar molecule which induces the dipole in the non-polar molecule, so that a temporary interaction exists, and such interactions are very weak interactions. Okay. So, bond strength wise, if you see the primary interactions which are intramolecular like ionic, metallic, covalent, they are the strongest bond, and intermolecular interaction like hydrogen bonding, dipole-dipole interaction, induced dipole interaction, they are the weakest interaction. But mind you, most of the materials, they contain both type of interaction, both primary as well as secondary. Generally, the primary type of interaction provide strength to the material, whereas secondary interaction sometimes provide some structural deformation to the material. Okay. Now, identify what type of bonding exists in the following material: solid xenon, van der Waals interaction, okay. Calcium fluoride, ionic interaction. You can say calcium is a electropositive element, fluorine is a electronegative element, or you can say calcium is a metal, fluorine is a non-metal, so interaction is ionic. Then cadmium telluride, both are non-metals, so both are electronegative element, so the type of interaction is covalent. Synthetic rubber, which is nothing but a polymer, what is the type of interaction? Covalent, a polymer. For example, if I say polythene, so n number of CH2 molecules, they combine to give a giant macromolecule that is called polythene. This is polythene. So, what is the nature of bonding here? It is covalent. Bronze, which is an alloy of copper and tin. So, copper is a metal, copper plus tin. Copper is a metal, tin is a metal. So, the combination of copper and tin, the type of bonding is metallic bonding. Tungsten carbide is a typical example where all three types of bond exist: metallic, ionic and covalent. So, what is our conclusion for today's topic? Formation of material irrespective of their class, whether that belongs to the conventional metal type or smart material or advanced material, irrespective of the class, they involve one or the other type of chemical interaction, whether it is primary interaction or secondary interaction. Means material formation is possible only if there is a chemical, only when there is a chemical interaction between the atoms of different elements. And moreover, degree of each interaction may be controlled during the processing of a material. So, it is in the hand of the person who is responsible for processing the material, which interaction will be more stronger, which interaction will be more weaker, that all these things the engineer or the chemist will decide, degree of each interaction, and the degree of processing, the degree of interaction, the controlled interaction, the level of controlled interaction will decide the structure of the material, and the structure is related to the properties. So, degree of each interaction may be controlled during the processing of a material in order to obtain a desired structure, so that a predetermined set of properties can be realized. Suppose an engineer wants that the iron, the steel that he is going to manufacture should contain more amount of carbon, then accordingly he will change the carbon percentage during the processing. And once during the processing the carbon percentage is changed, then accordingly the structure of the steel will change, and depending on the structure the properties the material will exhibit. So, now what is happening, theoretically a property is decided, the engineer conceptualizes the property, that what properties he desires, based on that he gives the prescription, he gives the recommendation to the processing unit to how to synthesize the material, so that it will lead to this set of properties and the required set of properties can be realized. Okay, then thank you. I hope you have enjoyed my topic. So, thank you very much.
వ్యవహారాల కేబినెట్ కమిటీ, ఆప్షన్ బి భారత పార్లమెంటు